Assalamualaikum warahmatullahi wabarakatuh. Good morning. And in this video, I'd like to share with all of you, or we're now continuing our lecture, the topic 8 of limits and continuity. Okay, so I do hope that all of you are ready with your lecture notes in your hand right now. So there are three parts that we discuss in this topic, which is the first, limits, asymptotes, and continuity. The first part of this topic, 8.1, limit. Okay, we're gonna look into the content. What is all about? We call the limit in this part here. Okay, determine, we call the approach of a limit given the value of a and the basic properties. Limit of the function of we call fx divided by gx, and also one-sided limit and the existence of a limit of a function. So in mathematics, limit of function refers to the number of L, which is a fx approach as an x approach to a certain value of a. In other words, we will look at the behavior of the fx as x comes closer and closer to the value of a. Okay, so just look at this one here right now. Fx equal to an L. Okay, x equal to a. Okay, so fx in this part we may also define as a we call the y-axis or fx here. So now x approach to a. So just imagine that if x equal to 2, let's say x equal to 2. So imagine that the value of x approaching to 2 from left, from 0, actually that is from negative here, from negative 2, negative 1, 0, 1, 1.3, 1.5, 1.6, 1.7, 1.8, 1.9, 1.99, 1.9999, you just name it, any value of x that push to a from left, then, okay, x approach to a from left. So look at this one, the graph here. X approach to a from left, meaning that the graph approaching to the value of something here, which is L. Okay. And if you refer to the value of y, okay, the value of y is approaching to the value of x. So, okay, when x approach to a, then the function approaching to the value of L, somewhere around here of value of y. And also, when x approach to a from right, when a equal to 2, just imagine that x approach to a from right, okay, 5, 4, 3, and then 2.5, 2.3, 2.1, 2.001, 2.0001, okay, getting closer and closer to the value of x, approach to we call equal to a, and you can see here the graph approaching to the value 1 value, and if we refer to the value of y here, x-axis approaching to the value of y from above. Okay, so look at the graph then here, approaching to the value of L from left and right. Okay, from right and also from left. And then the value of y, x equal to L here, approaching over the graph of y approaching to the value of L from above and from below. So then x approach to a from the left and right, fx approach to a certain value of L. So definition and limit of function at any given point, if fx came closer and closer to the single value of L, x approach to a from either side, then from either side, left and right, then the limit of fx, x approach to a equal to L. Okay. So this is how we read it. Now, okay, when x approach to a from right, okay, the symbol of plus means that x approach to a from right side. Okay, so the value of x all are greater than a. So when let's say x equal to 2, then x greater than a, because x approaching to x equal to 2 from right side. So if x equal to 2, then x here is 3, 4, 5, 6, and all the values which is greater than a. And also, this is x approach to a from left. Okay, so x approach to a from left, and these all the values of x which is less than a. And x approach to a from both sides, left and right, then we say that x approaching to a. Okay. Okay, so example here, let's say x equal to 3. As we know that in the topic of 5 function, when we substitute of x into the function of f, then it gives you an input of the value of y. Okay, so x is an input and y is an output. So we substitute x into the function of f, then it gives you the value of y. Now, x equal to 3. So if we substitute f3, then it come out, substitute x with 3 here, plus 3 equal to 6. This is when x is exactly equal to 3. Okay, but when we're talking about limit here, we're talking about the value of x that approaching to 3 from left, and also x approach to 3 from right. So just limit the value of x approach to 3 from right, 6, 5, 4, 3.5, 3.2, 3.1, 3.01, 3.001, 3.0001. Okay, approaching to 3 from left. And when x approach to 3 from left, so limit might be this area negative 2, negative 1, 0, 1, 2, 2.5, 2.7, 2.8, 2.9, 2.99, 2.9999. Okay, so then x approach, okay, for when x very close to the value of x equal to 3, so we just assume that x equal to 3. So fx approach to 3 from the left, fx will approach to 6. So when x approaching to the value of approaching to 3 from the left, so this is the graph. It's approaching to one value of y. Approaching to one value of y here from left, from down, and also when x approaching to 3 from right, we recall the graph approaching to the value of y from right or above here, sliding down. So then, as an x approach to 3 from left, then fx equal to 6. Okay, it might be not exactly 6 because it's the value of x just approaching to 3 from left, but not exactly equal to 3. Okay, and also x approach to 3 from right, fx will approach. It's not exactly 6, but approaching 6. Okay, getting closer to 6. Then fx approaching to 6. Okay. So the notes limit fx approaching a from left and also limit fx approaching to a from right equal to an L. So the limit fx when x approach to a equal to an L. Okay. In this topic, we are talking about limit approaching to A from left, approaching to A from right. It's not exactly x equal to A. So then, if limit of fx approach to A from left and right are not equal, then the limit does not exist. Okay. From the table, limit of x approach to 0, from recall x squared plus 1. Okay. This one I'm saying, this one I'm talking about. X approaching to A from the left. Okay. So when x equal to 0, this is x exactly 0. And these all values of x approaching 0 from left and approaching 0 from right. Okay, the value of x approaching 0 from right and x approaching 0 from left. So when x equal to negative 1, negative 0.5, negative 0.25, negative 0.0001, negative 0.000001, you just name it. Okay, as long as it's not exactly 0. So x approaching 0 from the left, fx is getting closer to 1. And also, so we say that x approaching 0 from left, fx approaching 1. Okay, so we didn't say that the value of x is exactly 0, but when a value of x too close, when value of x too close to x equal to 0, so we just assume that x equal to 0 here. We assuming here. Okay, it's not exactly x equal to 0. So just substitute x equal to 0, 0 squared equal to 0, plus 1 equal to 1. Okay, and now when x approach 0 from right, fx getting closer. Okay, so this is a keyword, getting closer. It's not exactly 1. Okay, so when x approaching 0 from right, then fx approaching 1. Okay, so it's not exactly 0, but a value of x that very close to 0, okay, from right. So we assume that the value of x equal to 0 here, because if we say that 0.00001 square plus 1, okay, you just imagine that 0.00001 square, then it becomes 0.000000001 and plus 1. So we assume that everything here equal to 0. So 0 squared plus 1 equal to 1. Okay. Limit from the left equal to 1. Limit from right equal to 1. From left and right, they are approaching to one value of y or L, which is 1 and 1. Then the limit x squared plus 1, when x approaches to 0, it is equal to 1. Okay, from the graph, this is the graph of x squared plus 1. Okay, limit x approach to 0 from left equal to approaching to 1. Okay. Okay. If x is exactly equal to 0, so when x exactly equal to 0, 0 squared plus 1 equal to 1. And limit x approach to 0 from right. Okay. Okay. X approaching 0 from right. Okay, even mentioned here x greater than 0. So the right direction from the right 2x approach to 0, opposite of this one here, when x is getting closer, so we just substitute x equal to 0. 0 squared plus 1 equal to 1. Just now. Okay, look at this one here, approaching to 0 from right. Okay, so then x equal to 1. So from both left and right, is approaching to one value of y, which is 1 here. So then, limit of x squared plus 1 when x approaching to 0 equal to 1. Okay. So the properties of limit, so please refer to this one here now. Okay. So direct substitution. The limit of certain function may be evaluated by substitute x equal to a into the function such that limit of fx equal to x approaching to a equal to fa. Direct substitution. Okay, so let's take a look at the first one here now. Okay, the first example here, a, limit the function of ln 4 when t approaching to 3. Okay, in this question here, there is no variable or unknown of t. Just like the equation of the sample example of b here, when x approach to 4, there is a unknown of x. When x approaching to -1, there is an unknown of x here. But for the first one here, there is no unknown of t into the function of fx, which is only ln 4. So it is equal to natural log of 4 here. Okay. Next one. If we substitute the value of x with 4 into the function here, square root of x minus 2. Even though if it's equal to 0, 0 is still a value. So we can just simply substitute the value of x into the function, which is square root of 4 minus 2 equal to, okay, square root of 2. And next one here, we substitute the value of x with -1, it becomes 2e to the power of x equal to -1 plus 1. Then come up with 2e to the power of 0, where e power of 0 equal to 1. Then it is equal to 2. Okay. Next one. Okay, what about this one here now? We substitute x equal to 2 here. 2 minus 1 equal to 1. So natural log of 1, it still gives us a value where natural log of 1 equal to 0 plus 5. Okay, we substitute the first one here when x equal to 2, natural log of 2 minus 1 plus 5 equal to 2 minus 1 equal to 1, and natural log of 1, natural log of 1. Please press the calculator and test the recall. Give me the value then. Yes, natural log of 1 equal to 0. So 0 plus 5 equal to 5. And now, what about this one here now? Limit x approach to 3. So we substitute here with a limit of 3 minus 2 equal to 1. And here come out with a limit of, okay, cube root of limit x approach to 1, limit of x squared plus 1 divided by x plus 1. Okay, so then here now, cube root of, substitute x equal to 1, 1 squared is 1, plus 1 equal to 2, and also substitute x with 1, 1 plus 1 equal to 2, then come out with 1. 2 divided by 2 equal to 1, cube root of 1 still equal to 1 here. Okay, direct substitution method, the limit of rational function, rational function. So rational means that it's something that you call an fx divided by gx. Okay, can be found by direct substitution when the denominator is different from 0, meaning the denominator is not equal to 0. Okay, so limit of function of x approaching to a fx gx provided when ga is not equal to 0. Okay, so let's see now whether if we direct substitute x equal to 2 into this both of x, will it give you 0 or not? Okay, so the limit x approach to 2 for x cubed minus 4 divided by x squared minus 3. Okay, substitute x equal to 2, 2 cubed minus 4 divided by 2 squared minus 3. 2 cubed equal to 8 minus 4 divided by 2 squared equal to 4 minus 3 equal to 4 divided by 1 equal to 4. So it's not a 0 here. Okay, the denominator is not equal to 0, so we can just directly substitute the value of x into the function. Direct substitution. Okay, if both fx and gx are function, when you substitute the limit, it gives you a 0 and also 0. Okay, limit of x approach to a for fx gx equal to 0 over 0. If this happens, then this is called the indeterminate form. So then we are not going to substitute, straightly substitute the value of x equal to a into the function of fx and gx. So this can be solved by either using the factorization or multiplication of conjugate. Okay. Okay, now let's take a look at this one here. When x equal to 2, substitute here 2 cubed equal to 8. 8 minus 8 divided by 2 squared equal to 4. 4 minus 4, which is 0 over 0. So then we are not going to directly substitute the value of x equal to 2 into this both of x into the function. So what can we do now? So now, factorization method, which is limit x approaching to 2 for x cubed minus 8 divided by x squared minus 4. Okay, so for this question, we are going to come up with limit x approach to 2, factorize this, and we can get one of the factors, which is x minus 2 and x squared plus 2x plus 4 divide by, factorize this, x squared minus 4, it gives you x minus 2 and x plus 2. X times x squared, 2x and negative 2x equal to 0, then negative 2 times 2 equal to negative 4. So look at this one here now. Clear these two. Then we substitute x equal to 2 into the function. 1 by 1. 2 squared equal to 4. 2 times 2 equal to 4. Plus with 4. Divide by x equal to 2 plus 2 equal to 4. So then now become 12 divided by 4, which is equal to 3. Okay, next, find the limit of this. Okay, we substitute the value of x equal to 2. 2 minus 2 equal to 0. Substitute here, 2 plus 2 equal to 4. Square root of 4 equal to 2. 2 minus 2 equal to 0. So we don't want this happening. So the best thing we can do here now is limit x approach to 2, then x minus 2 divide by square root of x plus 2 minus 2. Okay, look at this one slowly one by one. Okay, class, for this question, we are going to multiply this function with a conjugate of denominator. In this case, we it's not the purpose of multiply with the conjugate to eliminate this sign of square root sign here. The purpose or the reason we multiply with the square root sign, because we don't want, okay, we try to avoid the denominator that become equal, the denominator equal to 0. Okay, so again, 2 plus 2 equal to 4. Square root of 4 equal to 2, then 2 minus 2 equal to 0. We're going to try to avoid that. So let's take a look at this one slowly. X approach to 2. So then x minus 2 divided by square root of x plus 2 minus 2. Okay, and this one here multiplied with square root of x plus 2 plus 2. Okay, conjugate means that we change the sign of this negative 2 with a positive 2 here, and divide by square root of x plus 2 plus 2. Then, okay, now we multiply 1 by 1, x multiplied with this, x multiplied with 2, then negative 2 times square root of x plus 2, and negative 2 times positive of 2. And also here, so we come out with a limit x approach to 2. Okay, you try, so we call to expand this 1 by 1. So what I get here now is square root of x times square root of x, which is x plus 2. And then square root of x times 2, and also here negative 2 times this one equal to 0. Then here negative 2 plus 2 equal to negative 4. And then multiply, expand of this one here, it gave us what we call an x minus 2, and then square root of x plus 2 plus 2. So this gives us that we call become x minus 2. Okay. Now let's try. We substitute the value of x equal to 2 here. Okay, before that, we got x minus 2 here, and also x minus 2. So equal to 1. So what we have here, what we got here now is only square root of x plus 2 and plus 2. Substitute x with 2 here. Okay, then square root of 2 plus 2 and then plus 2 here. Square root 4, 2 plus 2 equal to 4. And square root of 4 equal to 2, then plus with 2 here equal to 4. Okay. Multiplication of conjugate. Okay, so now find the limit of this. Find the limit of this one here. So then limit of x approaching 0. Okay. If we substitute x equal to 0, then something over 0 is undefined. Even here, we substitute here with 0. So square root of 1 equal to 1. 1 minus 1 equal to 0. And also 0. Okay. So we avoid that. Now 1 minus square root of x plus 1 divided by x. We multiply this with 1 plus square root of x plus 1 divided by 1 plus square root of x plus 1. Okay, now let's expand this 1 by 1. Okay, expand it. 1 times 1 equal to 1. 1 times this, okay, and then negative x square of x plus 1 multiplied with 1, negative 0. So negative times positive, negative square of x square of x plus 1 multiplied with square of x plus 1. Then we got x plus 1. Okay, now x multiplied with 1 equal to an x, and x multiplied with square of x plus 1 plus with x square root of x plus 1. Okay. Then now we substitute x equal to 0. Or before that. Okay. So I'm sorry, we are not going to recall substitutes here right now, but then we're going to simplify first. Limit x approach to 0. Okay. 1 minus x, and then negative times positive 1 minus 1 divided by, okay, look at the denominator here, x with an x, so factorize with the 1 plus square root of x plus 1. So 1 minus 1 equal to 0, and then negative x divided by x here, x divided by x. Then they give us limit x approaching to 0, they give negative 1 divided by 1 plus square root of x plus 1. Okay, so let's substitute a bit of x here now. X equal to 0 here, so 0 plus 1 equal to 1. Then negative 1 divided by 1 plus 1 equal to negative 1 over 2. Okay, next, okay, class. This is the, if you realize, recall from your previous knowledge, if you look at this form, okay, this question here, the function here, it reminds us to what we call the differentiation, right? Yes, limit is the beginning of the topic of differentiation. Okay, so if fx equal to square root of x or x to the power of 1 over 2, then differentiate the function of fx respect to the x equal to half, okay, bring the power in front here, and half x to the power of half minus 1, and give us negative 1 over 2. Okay, so this is the final answer that we should get at the end of this question here. Then now, limit h approaching to 0. okay, the function of fx plus h minus fx divided by h. Okay, now look at the function of fx here, square root of x. So now limit h approaching to 0, which is square root of fx plus h. So just imagine that we substitute x here for this function with x plus h. So x plus h minus fx, which is square root of x, and divide by h. Okay, now if we substitute h equal to 0, then square root of x minus square root of x equal to 0, divide by h equal to 0, 0 over 0. So avoid that. So in this case, we are going to multiply with the conjugate of the numerator of this, which is square root of x plus h plus, look at this one, negative, and turn it into positive here, square root of x divided by square root of x plus h plus square root of x. Then, okay, now limit h approaching to 0, square root of x plus h multiplied by square root of x plus h, and we get x plus h. Okay, because it's a conjugate, okay, this is a conjugate of this one, of the term here, of the numerator, then we can just simply simplify this as a negative times positive is negative, then square root of x multiplied by square root of x equal to an x. Then h multiplied with square root of x plus h plus with square root of x. Okay, x minus x. Then h divided by h. Then you come out with limit of h approaching to 0. H approaching to 0 when x minus x equal to 0. H divided by h equal to 1. Then you come out with 1 over square root of x plus h plus with square root of x. Okay, now we can substitute the value of h equal to 0. There's only one h here. So when h equal to 0, then only 1, okay, then only 1 divided by square root of x plus square root of x left, equal to 1 divided by square root of x plus square root of x. Okay, so now this is 1 over, okay, square root of x plus square root of x equal to 2 square root of x. Don't you think that this equal to this one here? Okay, this also can be written in the form of 1 over 2 x power of negative half, which is also x to the power of half from denominator. So this is the correct answer. This is the answer that we're looking for. Okay. So now, case study here, a two-sided limit, okay, x squared minus 9 divided by x minus 3, okay. So the data we call the domain of this function is all values of x except when x equal to 3. Why? Because if x equal to 3, then 3 minus 3 equal to 0, then the whole function is undefined. Okay, and also for x squared minus 9, when 3 squared equal to 9, 9 minus 9 equal to 0. So for this one here now, we factorize x squared minus 9 into x minus 3 and x plus 3. So then clear this. Now we can find factor because substitute the value of x equal to 3 into the function. 3 plus 3 equal to 6. And also when x approaching to 3 from right, okay, this is x approaching to 3 from left. Okay, when x equal to 3 here, so we're looking at the behavior when x approaching to 3 from left and x approaching to 3 from right. So when x approaching to 3 from right, okay, factorize this and divide, and we get x plus 3. Substitute x equal to 3 here, and it's also equal to 6. Okay, so the graph will be something like this. Okay. Okay, when x approaching to 3, so we're talking about x equal to 3 here. 3 from the left and 3 from the right. So approaching to 3 from the left and 3 from the right. So look at the graph, approaching to one value of y here, which is y equal to 6. This is not exactly 6 and not exactly 3, but then the behavior of the graph approaching to one value of y, which is equal to 6. Okay. So then we can say that the limit of this function of fx when x approaches to 3, which is equal to 6. A two-sided limit. Okay. One-sided limit can be either left or hand limit or right hand limit. So left hand limit, the limit of f as x approaching to a from the left is L. Okay, so x approaching to a from left. Okay, so look at the we call the function here. There is no graph from the right side of the function of f from x approaching to a from right. Do you find any graph here? No, right? There's only graph slightly we call moving approaching to x equal to a from the left side. So look at this one here now. Okay, so limit of x approach to a from left of the function fx equal to L. And also right hand limit. Okay. So now, okay, the graph, for example, there is only graph approaching to x equal to a here from the right side. Okay. From the right, there is no graph from the left. Okay, so then take a look at this one here now. The movement of the graph from the right side approaching to the value of x equal to a. Which I think that we may need to make some adjustment or correction here, approaching to a from the right, which means that a is supposed to be here. Okay, sorry. So relation between one side and two side limit. So when x approaches to a from the left and right equal to L, then the limit of fx x approaches to a equal to an L. Okay, limit exists at x equal to a. And then if x approaches to a from the left is not equal to the limit of fx when x approaches to a from the right, and the limit does not exist. Okay, now solution. Okay, so for this one here now, just imagine that when x equal to 4, okay, if this is x squared, okay, this we call this is the domain of the function for x squared, and also x squared here. But when x exactly equal to 4, then the value is 0. It's not x squared anymore. Okay. So for this one here now, okay, let's take a look at the graph of this. Okay, so the graph will be something like this, because function of x squared is the graph of, okay, at origin point here and moving up. So y equal to x squared. And when x equal to 4, let's say 4 here. Meaning, okay, now when x approaching to 4 from left, okay, and also x approaching to 4 from right. So the limit of x approaching to 4 from left equal to x squared. So when x equal to 4, we just substitute 4 here, 4 squared equal to 60. Okay, when x approaching to 4 from left, the graph moving up here, let's just imagine that this is 16. Just imagine this 16 here. And when also x approaching to 4 from right, the graph moving to the one value of 16 here from above here, from right, then the limit x approach to 4 from right for x squared also equal to 16. Then we come up with the conclusion that the limit x approach to 4 for the function of x squared equal to 60. And what about this one here now? Okay. When x equal to 0, x less than 0 is we call the domain of x for function of x squared. Okay. This is for the function of x squared and x greater than 0. And this is for 1 plus x. Okay. So now, okay, graph x squared. Graph of x squared is something like this. Sorry. Okay. But then, this function of x squared valid for x less than 0, meaning okay, for x less than 0. So we are talking about the value of graph which is left side of this. So now erase the rest of it. There you go. So then this is the graph of y equal to x squared, fx equal to x squared for x less than 0. And then for this function, okay, when x equal to 0, y equal to 1. And when y equal to 0, 1 plus x equal to 0, then x equal to negative 1 here. 1 and 1. So the graph is a linear straight line, something like this. But then this function is valid for x greater than 0. So there is another thing that we need to consider here. It's only valid for x greater than 0. X greater than 0 means that it's only for this part here. So now we erase the rest of it. There you go. Okay, so this is a graph of fx approaching to 0 from right, and this also the graph when x approaching to 0 from left. So now limit x approaching to 0 from left. From left is a function of x squared. So then 0 squared equal to 0 squared equal to 0. And the limit of x approaching to 0 from right. And approaching to 0 from right for the function of 1 plus x. So 1 plus x. So substitute x equal to 0 here. Then 1 plus 0 equal to 1. And they are not equal. So then the conclusion here, limit x approach to 0 for the function of fx does not exist. Okay. Finally, of these two, does the limit exist? Okay. So then from here now, for absolute values of x, we can come up with x and also negative x. This is for x greater than 0 and x less than 0. So in number line here, 0, this one for x less than 0, the function is negative x, and for x greater than 0, is that function of x. Okay, now limit x approaching to 0 from left. From left, which is negative x divided by negative x divided by x. So look at the question before previous here. Okay, this one here, modulus of x divided by x. Okay, so negative x divided by x equal to negative 1. And limit x approaching to 0 from right. This one, x approaching to 0 from right, and the function is x. So then, x divided by x equal to 1. So, they are not equal again. Therefore, limit x approach to 0 for the function of modulus of x divided by x does not exist. Okay, exercise for this. Okay, for the exercise of this, which I think that I give you the final answer for this one here. Find out when the x equal to, or the limit. Okay, so for these two exercise, which I think that I'm going to leave to all of you for you to try. Where the final answer of this final answer, which is the limit does not exist. x does not exist. Sorry for the terrible handwriting there. Okay, you try with yourself and find the answers as the limit does not exist. And for this one here, the limit, okay, the limit of this function is x equal to, limit is 2. Okay, the limit of the whole function here, which is equal to 2. Okay, so the conclusion here, indirect substitution method failed, so getting the intermediate form. So we come up with the method of factorization for both fx and gx are polynomial functions and multiplied by its conjugate if either one fx or gx are function in search form. Okay, that's all for today. Till we meet again, and that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.